The next thing I'll just talk about, now we've seen you back online, is ADAC. What ADAC is, it's as designed, as constructed. It's a format that started in Queensland, and now it is hopefully going to extend further than that. And what it was for was a council type work to bring in data sets of as built. That was the whole idea. Instead of getting things in all sorts of weird ways, if it came into as an XML file format, then they could read into their GIS systems and actually take it in, rather than you having to give them tables and things like that. The whole idea about an XML format is they then define exactly what's in it, so it's therefore a text file and vendor independent. So anyone should be able to take it, read it, and or produce it. And it's designed for specific 3D data sets. So they've defined what should be in there, how you put them in there, what values you can have. All that has to be specified for an XML file. And it's supposed to be, though, providing survey accurate as-built data to go back to councils for the assets, drainage networks, sewer networks, and so on. The good thing about it is then an electronic format, which means one hopes that, again, bit by bit, all the paper documentation that can start disappearing. There are a few other things around. Why I think this one will gain traction. There's other ones around called D-Spec, A-Spec, R-Spec. They've come out of Victoria. It's actually from a private organisation. The only problem with them is, and the guy is quite proud of the fact that there is no file format. Now what that means is every site you go to could ask for their files in a different format. They might want them in shape files, they might want text files. So unfortunately, every time you go to one of those sites, what you have to produce is totally different. Whereas this, they have specified the format that we have to write and read in. So that's why this should gain traction, and the other ones are just hopeless for trying to get things to be implemented from one site to another. So this one should gain traction for that reason alone. We've been involved with ADAC since 2005. We gave demonstrations in 2005, then ADAC went to sleep. Now I know this is a government organisation, so these things happen often, but all sorts of things happened in the background, and they came back out in 2011 with a totally modified format, which looked not much at all like the original format. So basically we had to go through and rewrite what we were doing. But we had some very definite ideas about ADAC. We're not interested in just typing in ADAC data and writing out an ADAC XML file, so basically filling in stuff in a spreadsheet. Yep, you can do that, and we can actually do that with what we're doing. But that's basically just a manual data collection exercise. You have to do it afterwards at great expense, and what's the use? No different to you putting them into a table now. What our whole aim from day one and why we got involved with ADAC, we want to make sure the data format could round trip 3D civil data. That is, we just don't want to be able to write out ADAC XML file. We want to be able to read it back in, say, to 12D and make something sensible out of it. That side was not really thought about too much because they were talking about, oh, we just want to get our data into our GIS systems. We said, well, no, we would like to be able to build a network from it. Because my idea was, you give them all this ADAC data, then down the path you might be able to reuse it. So we wanted to integrate the collection of the ADAC data into the normal design, construct, as-built workflow, and I'll discuss that in a second, because most of the data in ADAC, it's all your things like your sewer network, your drainage network, potentially other things, footpaths, things like that, they should already be in your design. And all that data, if it's in there, shouldn't have to be re-entered. And the as-built pickups, well, you really should just be modifying the design. The only thing that should change, hopefully, is the coordinates of where the manhole might be, and a few things like that. But the rest should pretty well be the same, unless it's a total redesign. Well, you'd have a new design anyway to pick up. So we saw it not just as being able to read in the little writing an ADAC file out the side there, but we should be able to go to someone and say, for a council, I'm going to work in this area, give me all the past ADAC files that have been there for it, so I can read them in, and that should give me my as-constructed network of all that 3D data. You may have to add other things into it, surveys and so on, so the designer can use that ADAC data in the future as his previous ADAC data as the start. So that's how we saw it working. You'd use the ADAC files coming out of your existing ADAC systems from the councils, pulling data from maybe GIS, go out and do detailed surveys, and that would be all part of what the designer works with. And so the designer would go away, put in his drainage networks, his sewer networks, his roads, whatever else he's designing. That would then go out to the construction company. You give him your 12D data to design, they would go out and construct it. And then when it comes to the final stage where ADAC sort of comes in, is that the person picking up the as-built, he should have the design to start with. Because when you go out in the field to pick something up, if you've got the design, you can say, where is manhole A3497? And it should be able to guide you to where it is. If it's not where it's supposed to be, that's a good thing to say to start off with, there's an error. You go out and then do a reading, its coordinate would possibly be slightly different to what it was, so you would modify that. But the type of pit, all that information, that should have not changed. If it has, they've built the wrong thing out there. So you really should be only having to go out there if you've got the design to double check what it is and modify a few coordinates and things. So that's how it should be working, we see, in the whole workflow. Then the final step is there may be data in there that didn't come from the designers. There might be some asset numbers, other things. Yes, you might go and add some extra data to the ADAC. That's what's required. And then you write out your ADAC file. Or you would also have your data to go into your GIS system, or you'd have reports and everything else. So ADAC should be just one little part of this whole loop. And that's how we thought of it and how it should be working and what we've been working on. So what we're actually doing, brave man I am, Alan Gray is going to demonstrate basically doing some of these processes, reading in the ADAC XML, the new version that came out just last year, to produce a drainage network, say in this case. You normally could then go and create 12D data or whatever. You know how to do that. We're not going to bother. What we'll do though, we'll then just show you how all the ADAC data comes in, then into 12D with attributes and things. So you could add things, edit them inside 12D, or basically do whatever you want and then write out the ADAC XML. And then I think Alan reads it back in again. So just to show you can go around the loop. So we're just going to fire up and see how it goes. Keep our fingers crossed.
As mentioned, ADAC is XML. So as Hans said, there are already millions of different XML file formats out there. So ADAC have gone and created what's called the XSD or the schema definition, and that tells an application or a viewer or whatever how the data is structured within the XML file. So that's what XSD is all about. I'll come back and show why that's important in a second. But first off, we have a little project here which has lots of, it's a fair-sized drainage network, so if we zoom in far enough we can see our pits and pipes, etc. So our first little task is we're going to go... Okay,
actually, before you go anywhere, Alan, can you just check what are the attributes like on there at the moment?
At the moment, there are no attributes, none whatsoever.
So you just pop up a...
Yep. So, see, this is why I always have troubles, because he just keeps wanting to vary my demo from what I've practiced. He never learns.
The problem with the programmers is they usually don't know where the options are.
Okay, so this drainage network has lots of 12D attributes, and on the pits, a lot of calculated attributes. So obviously someone has run a probably a rational method analysis on this job. Now that's all the attributes it has. Our philosophy with ADAC XML, and this will apply also for other XML file definitions as they arise, and we know they will arise, is that we should be able to host that data inside 12D model as seamlessly as possible, which actually means that we can read an ADAC XML file, read into 12D, it'll construct, for example, a drainage network. All the ADAC attributes are there. We can rewrite an ADAC XML file and basically should get the same ADAC XML file in structure. So you can actually transport ADAC XML via 12D ASCII or 12D XML, which is a bizarre concept, but that's the way it turns out. So what we're going to do, we're going to be the real lazy man's approach. We're just going to say, right, I want to go on export this drainage network, and looks like it's an old panel, but I don't know why that ticks there. That's the wrong name. But basically what that's supposed to do is we have all the pit geometry, all of the pipe information, and with the drainage.4d file, enough information to automatically write an ADAC file. So we're going to write a file called conf 2012. Actually managed to spell it this time. And then we're going to try to open it. In this case, it's going to pop up for me in Internet Explorer, and I hope it doesn't hang this time, because Internet Explorer doesn't really like big XML files. It can sit there for 10 minutes consuming a 1 megabyte file. So obviously, if that's the benchmark that we have to meet, we're quite happy that that's Microsoft's benchmark for us. So here you can see we have an ADAC file. At the top it says it's ADAC, and then every element in there will have this ADAC prefix, and then there's a whole bunch of attributes about export time, coordinate systems, and then we'll get down the interesting stuff of stormwater, pits and pipes. So that's running that file. We're now going to dismiss that, and we'll come back to read. And we're going to say, okay, let's go and read back in that same conf 2012, and I want to read it into a model prefix called conf 2012 star. And my God, it worked. It's alive, it's a miracle. We're going to add on conf 2012. Toggle that text off, and maximize our view there, and if we jump between the two, sorry, just do a fit so they kind of line up, we should actually see that they probably overlap each other. Oh, well, I've got other data on this view, so not exactly. So now, the question that Lee posed before was, okay, if we go back to string attributes, attributes, not strings, vertices, section, pits, pipes, etc., and pick a pit and pipe, we now have this new subnode on the pit called ADAC. And inside that pit, it has got every single attribute in exactly the same structure that exists inside the ADAC XML file. So this is where we're just preserving the ADAC or XML structure hosted inside 12D model, which gives us an awful lot of power, because as new elements or objects are actually added to the ADAC definition, and currently they're on 4.0, and 4.1 is either soon, imminent, or in the next period. That means our code should just work. We don't have to keep modifying 12d.exe every time they change something. That's the theory, and it hopefully will be proved to be true. And again, for the pipes, we've got various attributes. So, there you can see, they've got their object ID, their component info, all that sort of information. And here, for example, they've got this concrete cover type, and it's standard. Now, in this form, that attribute is just text, so it doesn't know what are all the choices for the concrete cover type. Is it standard? What are all the choices? So what we did go and do is, because we've decided to use XML so extensively in 12D model now, we decided we would now go and write our own XSD engine. So what that means is an XSD file is just another XML file. So it's kind of a recursive definition. But XSD tells us all sorts of interesting things. So for example, if we go and read that conf 2012 file, we now have that file in an editor which is actually editing the ADAC XML file in its structure using the ADAC XSD definition supplied by IPWAEQ. Is that one too many letters? No. So what that means is...
He's had a tough night.
Yeah. So what that means is if we come down to our pits and pipes and we click on pit here, here's all our objects. We can actually now go and click on the same, it wasn't the same field, where were we? It doesn't matter. Under chamber construction, it knows what choices there are. So this is for the ADAC 4.0 definition. So if the 4.1 definition comes out with an additional choice, we are using the XSD file to drive an editor inside 12D to allow the user to edit an ADAC XML file. It doesn't have to be ADAC XML. It can be actually be technically any XML file that has a schema available. This generic editor will allow you to edit that XML file in a more intelligent fashion. So it'll know, for example, that under pits that you can add a new child, and that only child will be another pit. So under pits you're only allowed to have 0 or more pit elements. So yes, as far as XML goes, we've really gone to town with trying to implement the ADAC implementation in the most generic fashion possible. So if we go and click on our pick editor, how are we going for time, Lee?
You're okay. You confuse people enough. You'll be right.
That's good.
I can't.
Well, if I confuse them, they won't ask questions and etc. So here we are. We're actually using an ADAC pit editor. So we've gone and selected a specific pit within our drainage string. It goes, yes, I know where all those attributes should be hosted within the attribute structure of the drainage string manhole or pit. So we can come in here and now intelligently edit the data. So we can say, look, this data was owned by council. So for us, that's kind of ADAC in a nutshell. I mean, when we read that data in, we can go to a perspective view, and I'll go and add on, sorry, I'm running at really low resolution here because of the syncing problem. And just go and toggle shade on. And we'll just really mouse into, that's a much nicer area up there, into this section of the network. So I'm just using the touchpad. And just to make my life more difficult. And so that's the actual network itself. So that's what we see ADAC in a nutshell is, for us, it's just we've gone and done the most generic implementation necessary to support not only just ADAC but other XML definitions or even different variations of ADAC, so that we don't have to keep changing the source code of 12D model every single time that a new ADAC definition comes out. The theory should be is that the existing version of 12D should work. Now if they go and completely rearrange everything and turn the structure inside out and upside down, then that could be a case of all bets are off, and then you have to go and revisit the definition. But while they maintain the same basic structure, we can very easily support ADAC and its subsequent implementations or versions. So is there anything else I've missed there, Lee? Other than
with that, when we say we read the ADAC file, you actually could use this ADAC editor and the schema to actually just pull it up and type every bit of information in there. You don't have to have your drainage network, but that would be very laborious and not using information you've got. And the part we've done, yes, we've got all the ADAC attributes, but what we've done then is interpret them graphically. So ADAC does not tell us, or XML does not tell us how to draw a pit, or this is a pipe. It just says pipe and a thing called diameter or thickness or whatever. So our work in there is linking the fact of what their definition is and then drawing a structure that's represented by that. So if they go totally put something new that we haven't heard about before, well, we'd have to then write a thing to visualize it and so on. But in theory, yep, the editor would just pick up you could type everything in from scratch, because the file does format for the ADAC file, controls all that and tells you what you can put in there and away you go. But yeah, now the problem with the ADAC is, and well, that's what we'll be doing now. Now we've got 10 out. We had to add a lot of things for version 10 before we could finish the ADAC off. So we're now working on this now in our 11 and working with beta people, because before we had to have in rectangular pits. We had to have thicknesses, wall thicknesses. Your pipes just can't go to the centre, so we have to have connection points and things we were shown in version 10 in the drainage section. We needed all those things in there before we could now totally implement the ADAC. And some of the things in the ADAC are not necessarily quite correct. Where they might position things, they might be worried. Some of these systems, they work out grades that are different to what you might measure in the field. So we just have to worry about those things as well, but we can go as far as we can.